Hi, AP Stats. We're going to look at 5.2a, basic probability rules. So imagine flipping a fair coin 3 times. What are all the possible outcomes? If you want to pause the video right now and try and write these out, by all means do so. But what could happen? Well, I could get, why is it not writing? Heads, heads, heads. I could get tails, tails, tails. I could get heads, tails, heads, or tails, heads, heads, or head, head, tail. I could get one head and two tails, or tail, then a head, then a tail, or two tails in a row, and then a head. Let me think. Is there any other way I could do this? I don't think so. What we just created is known as a sample space. Sample space, which is the set of all possible outcomes of a chance behavior. Set of all possible outcomes of a chance behavior. Right? We have all the different possibilities here. So what if I asked, what is the probability? What is the probability that I roll, or I guess I'm not rolling. If I flip, I'm flipping a fair coin, right? If I flip all heads, the probability that I get 1, 2, 3 heads. Again, take a moment, pause the video if you want, but if we think about this, there are 8 total outcomes here, right? 8 possibilities, and heads, heads, heads is 1 out of those 8. It is, each of those outcomes is equally likely, so I have a 1 in 8 chance of this happening. What we just looked at, this right here, is known as an event. An event can be defined as a subset of the sample space. A subset of our sample space. Oops. And an event is often defined either by explicitly writing out the event like we did, or you can write it, usually they do capital letters. So let's say A is I flip heads only once. So if that was the event we are interested in, the probability of A here, the probability that I get only one head. Well, consider that. That would be this scenario, or that scenario. There are 3 out of the 8 where I flip heads only once, right? That's heads, tails, 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 heads, tails, or tails, tails, heads. Those are the different outcomes where this happens. Now, if I take both of these things, the sample space and the events, and I put them together, I create something called a probability model. A probability model is the sample space plus the probability of each outcome. And often this looks like a table. The most common way you're going to see this is in a table where we have X as an event and the probability of X as obviously the probability. So for example, heads, heads, heads is one of our pieces of our sample space. Then we've got like tails, 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 heads, heads, tail, etc., all the way through until whatever the last one we would have is, so like all of them, right? And those are that's a sample space. And then the probability of each outcome, well, in this case, they're all equally likely. So they would all have that probability. If it is a legitimate probability model, then these probabilities will add up to 1, which hopefully makes sense, right? If this sample space is all the possible ways this can happen, then if I would add up the probabilities of each individual of those happening, then it has to add up to 1. Let's look at an example where we've got the heads and the tails right here. What if I want to know the probability of getting 2 or more heads? The probability of 2 or more heads. Well, take a moment to consider, maybe pause the video, but 2 or more heads would be 3 heads, or 2 heads, or 2 heads, or 2 heads. There are 1, 2, 3, 4 options out of a total 8, or 1/2. We have a 50% chance of getting 2 or more heads. Another way you could look at this is 1 minus the probability that I get 1 or less heads. Because 2 or more, if I'm flipping a coin 3 times, 2 or more is the same as 1 or none. So we can look at it either way you want to. Take a moment, pause the video, find the probability of getting no heads, find the probability of getting at least 1 head. Probability of getting no heads, well, the only option, or the only time that's going to happen is if I get all tails. So that would be 1 out of 7. Oh, sorry, 7. That was really dumb. 1 out of 8, right? There's 8 total options here. And the probability of getting at least 1 head, well, think about this. That's the same as everything other than getting no heads. 1 minus the probability of no heads. So 1 minus the previous one, 1/8, we would get 7/8 is our probability here. Now you definitely could have gone in and counted all the times that you get at least 1 head, right? 1, 2, 3, 4, 5, 6, 7, and we get that same answer. But this idea is kind of important in probability. So let's look at the basic rules of probability. We'll start with the first one that we've seen before. The probability of any event is a number between 0 and 1. The probability of any event is a number between 0 and 1. I can write that symbolically by saying the probability of any event A has to be between 0 and 1. This is not new. Second fact, all possible outcomes in a sample space together must have probabilities whose sum is 1. All possible outcomes in a sample space together must have probabilities that sum up to 1. So if I say a sample space is made out of events A, B, and C, and I add the probability of A plus the probability of B plus the probability of C, I should get 1. Next up, we have if all outcomes in a sample space are equally likely, the probability that event A occurs can be found using the formula probability of A is equal to the number of outcomes corresponding to event A divided by the total number of outcomes in our sample space. You saw that on the last page. The probability of any event A is equal to the number of ways A can happen divided by the total number of outcomes in our sample space. Our next fact is that the probability that an event does not occur is equal to 1 minus the probability that an event does occur. So let's think about this. If I am looking at the probability of getting heads and the probability of getting tails, those together are going to equal 1, right? Those are the only two options. So the probability that I get tails is kind of like the same as the probability that you do not get heads, right? And so we could really write this as the probability of heads plus the probability of not heads is equal to 1. Notice to say not some event, they put this little c above. It's actually referring to the complement. AC is not event A. It is the complement of event A. Complement of event A. That's why it's a C. But back to this statement, let me go back in. Okay, this original statement was the probability that an event does not occur is equal to 1 minus the probability that it does. So we could really rearrange this and say the probability that some event A does not occur is equal to 1 minus the probability that it does. If there's a 80% chance you get an A on the next test, there's a 20% chance you do not get an A, right? It's everything left over. This is known as the complement rule. And then last but not least, we have our last statement. If two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. If two events have no outcomes in common, then the probability that one or the other occurs is equal to the sum of their individual probabilities. These kind of events, events that have no outcomes in common, are known as mutually exclusive. So again, I'm just going to rewrite it. Two events that have no outcomes in common. I don't know why my pen is being so bad right now, but that's okay. And so if I want to look at two mutually exclusive events, for example, let's think of a deck of cards. Let's say event A is I have a red card, and event B is that the card is a club. Well, if you know anything about decks of cards, which you might need to brush up your skills on, a club is a black card, right? The red cards in a deck are diamonds and hearts, and clubs and spades, which are these guys, are the black cards. And so do these two things happen together? Can I be both a red card and a club? No, I cannot. This is an example of two mutually exclusive events. They do not share any outcomes. So the probability that I am a red card or a club, well, that's going to be equal to the probability that I'm a red card plus the probability that I am a club. In this case, there are, well, half the deck is red, right? So that would be 26 out of 52. And clubs are one suit, so that is 13 out of 52. If I add these together, I'm getting 39 out of 52. We will, later in this section, go over decks of cards. So if you're like, I never know anything about decks of cards, don't stress out, you're okay. But for two mutually exclusive events, events that don't share any outcomes, The probability of either of them happening is equal to the sum of their oh my gosh, I'm so sorry. The sum of their individual probabilities. And with that, Belle, we're going to end this lesson. So have a good rest of your day.